Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Kyle from Business Review, and I'll be your host today. It's our pleasure to have Predictive with us, who's presenting this webinar entitled Process Industry, Predictive Analytics is Here to Scale. Today we have from Predictive, Chen Limchevsky, CEO, and Liet Avador-Peleg, CMO. I'd like to welcome you all to our webinar platform On24. You'll notice that this webinar is browser-based. So if you disconnect for any reason, please just click on the link you received by email to rejoin the session. If you want to ask any questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen, click submit, and we'll have some time at the very end to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But for now, please allow me to welcome Chen Limchevsky. Over to you, Chen.
Thank you. Thank you very much, and thank you all for joining this webinar. Today we're going to speak about scaling predictive analytics solutions in the process industry. As you can see from the beginning here, I'm going to talk more about the general needs and what's needed in order to make scale. I will not talk so much about SamGuard, our solution. So for those of you who may be disappointed or would like to hear more or get a demo, you're more than welcome to contact us after this webinar. But just in a few words, Predictive is a part of Samsung Group. The entire organization exists for 112 years, doing a lot of flow control for the process industry. Predictive specifically is based in Israel, started as a startup and now a mature company. Our product SamGuard is offered specifically for the process industry, chemical, petrochemical, refineries, oil and gas, and so on. Many customers with a lot of success over the entire worldwide organizations. And basically what we'll try to do today is to share some of the experiences, some of the thoughts that we were gathering through these years in order to try to help you scale your predictive analytics solution. So it's not about selling our specific product, which is great, by the way, but it's about how to take these solutions, which there is no question that can bring a lot of value, and actually make them scale and bring value not just to the specific plant, but over the entire organization. Now, we'll talk specifically about two topics, which we found as essential in order to be successful in scaling up. The first one is mapping the needs and resources. And when I'm talking about mapping the needs, I assume that you were talking about organizations which have, starting from one plant to hundreds of plants, and each plant would have its own needs and resources. And the second topic is about building the right implementation process. What are really the key things in building the implementation in order to be successful? And those two topics, when we started several years ago, seemed to us like so easy. And actually, we find that those are the two topics that if you handle correctly, you'll have a successful scale-up. And if you handle in the wrong way, you'll see some hiccups and disappointment through the way. So let's start with the first topic, which is mapping the needs. Okay. What we have found out is that each plant may have different needs. Now, it's not just if you're running a continuous plant versus a batch plant, but it may be that this plant was built 10, 15 years ago, and this plant was built 40 years ago. And this one is manufacturing a material which is really, needed, and there is the full demand. And the other one is kind of starting and stopping and starting and stopping. So each plant has a different method of operation. And as a result of that, the analytical needs of that plant may be different from one to another. Okay. One of the things that we saw as the major hiccup or the major problem in scaling up predictive analytics solutions is that when you're trying to start a project at the first plant that would like to do it versus the one that really have the need. So the most important thing is actually to map the need, and this is the hard work of mapping the need of each plant you're planning to integrate. Now, when we're looking in general, we see 5 topics that are the most common, and if you're planning to implement predictive analytics, think whether the needs are in any of these topics. Okay. The first one is, of course, part failures. Okay, this is the topic where our SandGuard solution is the most leading solution, where we are actually trying to tell you in advance that something is going to fail. But this is only part of it. Other problems are around process problems, optimization, golden batch, all these other topics, quality issues. All these topics are under the second bucket of process problems. Okay, there are plants which have both, but the focus is usually either part failures or process problems. Others who are very stable, don't have many process problems, but want to save on their energy consumption or other specific applications like that. People are talking about maintenance planning. I'll talk about it in a second. And there are always plant-specific problems which are not any of the topics which us as software vendors are handling, and it's a very specific problem for the plant, and this is something that you'll find in each plant. So mapping the needs is very important in order to start. Now, before I go into the details of each of these topics, I would like to ask you and to move to our host and try to check with you what would be your most relevant topic.
Okay, thank you. It is time for a poll question. So to everyone watching, to take part, please just click one option, click submit, and then wait for the next slide to view the live results. But our question today is, among the needs listed, which would you say is the most relevant for your plant? Would you say part failure, process problems and optimization, plant specific, plant maintenance, or other, energy consumption, etc.? Okay, so let's give everyone just a moment to think about that. But Chen, in the meantime, do you have any want to elaborate on this question a little bit?
Sure. So again, I'm sure that when you're thinking about those questions, probably all answers are correct in some respect. I mean, I'm sure people are experiencing unscheduled maintenance and part failure and so on, and probably many of you, especially in the batch processing, are fighting problems around quality and efficiency and golden batch and so on. What we would like to pick here is what's your focus? What would be the poster child that if you're coming to the plant manager and saying, yeah, we saved some availability because of part failure, or we improved the golden batch, or any other topic which is the most important for you. Okay, so this is now the what we expect here, and as soon as you're ready, we'll be happy to see the results. In a second.
Very good. Well, I think that's enough time now, so let's see how that turned out. Okay, there we have it. Does that look right to you?
Okay, interesting. So we're talking here about 26% of looking at part failures, 63 around process problems and optimization, 5.3 have their own specific problems, and I think the really interesting thing is about planning the maintenance, which got no responses here, and I think it's very aligned with what we're seeing in the industry and on our daily life. So let's talk about these parameters. So if we're looking at part failure, which 26% of you thought is the most important thing, when we're mapping the need here, there are two things that we need to keep in mind, okay? Because when we think about part failure, we usually think about a complete failure, which will eventually lead to availability. And later on, we'll talk how do we measure that. There is another aspect of that, which is the degradation, okay? Because part may still function, but function not as good as they function throughout their entire life. So a valve may become a little bit sticky. It's not a complete failure, but it's not as it should. And when you're mapping the needs, it's very important to set the expectations where we're actually trying not to only provide better availability, but also provide much better or strive into operational excellence and try to know in advance that these parts are now degrading and try to fix them or find a solution for this degradation, which eventually can affect also the other problems that you mentioned, which is the process optimization and process-related problems. Okay, so mapping the part failures is basically, I'm going to the plant, trying to understand, okay, what's your availability? How much of this availability was caused because of a part failure? How much of that happened before? Okay, and trying to see if this problem is really significant for the plant. Okay, now, in many cases, we came to a plant and the part failure was the kind of a highlight of the organization. And in reality, what you see is that not all failures, or most of the failures, are not around the most expensive, high-profile compressors or other equipment. So when you map this part failure, it's really important to notice that many of the failures and many of the degradations are caused not because of the high-level compressors, but because of the small valve, pump, and other small equipment, which eventually, under fortunate condition, may cause us those failures or those degradations, which eventually affect our operation. So part failure is the first need that we're looking at. The second need is, of course, the process problems and optimization. And in that respect, we see that mostly in batch production, less in the continuous plants, where the main problem is around, okay, what are the getting the golden batch or quality issues. So these two are the most common ones, as you also answered in the poll. The one thing that I would like to refer to now is the issue of the maintenance planning. And actually, when we started talking to customers many years ago, the anticipation from top management was around how can we save maintenance costs. Okay, and the value which was actually intended is how can we know in advance when a part is due and only then replace that part. Now, in that respect, I'm very glad to see the results of our internal poll here, because it shows me that the industry has matured. Okay, in the process industry, in most cases, for the most equipment which is really critical, there is no real way of doing this on-demand maintenance. You're planning your turnarounds, you're planning your overalls, and the cost of the maintenance versus the cost of the risk are not really enough to justify taking the risk. So when we're talking now to customers, the things that they're trying to see is we want more availability, we want less failures, we want to have our process more optimized, quality stable, and so on. Reducing the budget of the maintenance is something that we see of less demand. And I'll tell you from the analytical perspective that this is also something which is, I would say, in the process industry, less realistic in terms of accuracy. Okay, we can predict part failure very nicely, hours, days, sometimes weeks in advance, and tell you have a problem with this part. It's very hard to make the second step and tell you a part is going to fail 6 months from now, but you don't need to replace it now. This is almost, from an analytical perspective, getting into really reliable results is not something that we can really say that we are able to do, and the same goes for other vendors. So set your expectations correctly. If you're looking at part failures, yes, it's doable. If you're looking at the process problems, yes, there are many things that we can do around the optimizations and finding the root cause for bad quality and so on and so forth. If you're trying to get the solution to tell you for each part when it's going to do, and you're going to trust it, and you're not going to replace it in the overall, but wait for it in order to save some maintenance costs, this is, from our perspective, less, I would say, realistic demand. Okay, so we actually look now at the 5, I would say, main or obvious things that appear when we're talking to customers around the world. Okay, now the question. So the first step that we need to do is to ask the plant, what is your real problem? Okay, and I can tell you from our experience that we started at the early days many pilots and implementations where this was not clear, and you think you're coming to a project where you're going to prevent part failures and the availability is 99%. Okay, the most important thing in this part is to make sure that you know what are the problems, and you're sure what will be your poster child, at least for the first year of implementation. Where are you going to show, wow, we increased availability, or we improved the process, or we did any other thing during this first year. And the organizations that were successful at scale were doing this mapping in the correct way. Okay, you know what you're trying to achieve. Okay, now, mapping the needs is only the beginning of the story. The second thing that you need to do is to basically map the resources. Okay, what are the things that are available for us? And these resources are starting with the data. Okay, so the first thing is data to achieve the goal, the need. So if I need to find that the part is going to fail, I would need the data, sensor data from those parts. If we are trying to optimize or to improve the quality, some quality data would be needed, and this is usually the thing that is the most obvious. Now, what we're seeing from our experience in the process industry is that it's very rare to find a plant that doesn't have, of course, DCS, and then that the data is saved in the historian, and there are tons of data, okay, hundreds and thousands and tens of thousands of tags, both of the process data and equipment data. And what we're basically, what we're often asked is it enough? And usually when we're looking at thousands of sensors, our response will be most likely that it will be enough. And what you would need is to load the data, in our case, into our solution, and we'll provide you, in this example, alerts about the potential failures of the plant. Now, the things that you should notice when you're looking at the data, from our experience, are two things. The first thing is digital tags. Okay, we have seen number of plants where instead of saving, for example, the data about the temperature itself, you would get a high-low temperature. Okay, 0-1 when the temperature is high, or when the temperature is low. Now, from analytical perspective, this is digital tags have some value, but not much. So if you're looking now, if you're assessing now, do I have enough data to do predictive analytics, to predict the next failure, or to improve my my quality, and so on and so forth? Try to check what is the ratio between digital tags and analog tags. Okay, and if most of your measurements are in the digital, okay, high-low flags, and pumps are only 0 and 1, meaning working, not working, but you don't have any other information about it, then you may have a problem. Okay. In general, when we're looking at the plant, and since we're covering the entire plant, we're taking all the data and we're trying to predict failures in improved process throughout the plant. It's the rule of big numbers. Okay, if you're getting a few thousands of tags, usually it's good enough. Still, if you're seeing that you're running around 1,000 tags and half of them are digital, it may be less accurate. The second thing that we're seeing is that you're coming to a plant and we have thousands of tags, but those thousands of tags are going through the DCS into the control room and are used for controlling the plant, but they're actually not saved in the historian. Now, analytics rely on historical data. Okay, so it doesn't matter which type of analytics and what kind of solution you'll select, you have to have the history. Now, in the early days, people kept in the historian only the things that they really needed, and they weren't open, or they weren't thinking about the new possibilities that we're providing right now of predicting failures and so on and so forth. So if you're in the situation where you're having most of the data available through the DCS for the control, but not saved in the historian, the sooner you'll start collecting data, the better. Okay, and if you're not doing, while you're doing the mapping, if you're seeing that most of the data or a lot of the data is not kept in the historian, this is the right time to say, let's start collecting the data. Because once you start collecting the data, it will take at least few months, and this depends on the plant, at least few months in order to have sufficient history in order to use this data in the correct way. Okay, so make sure that if to summarize this point about the data, usually historian data is not a problem. Keep in mind that the digital tags and the analog tags and in some cases the ratio of tags that are not saved in the historian and are available for control. But in that respect, what we usually see is that this point is in most cases is not a big problem. So we have the data to achieve the goal or the need within the process industry. The second type of data that we need, and this is more tricky, is the data that is needed to prove that the goal was achieved. Okay, and here we see that there is more of a guessing. Okay, because the data in the historian, the time series data is saved, but the data about, for example, utilization is often not really saved. Okay, and of course you have the availability of the plant. This is the number one goal for the plant manager. but not necessarily in the right split. So for example, do you know how much is planned versus unplanned? Okay. Do you know how much is preventable versus not preventable? For example, we had a plant where there had a lot of, or their availability was really low, but the main reason for that low availability was the electrical supply. Okay, they just didn't, the electricity was not stable, and they didn't get electricity to operate the plant. So if you're, it's really sad for the plant, but in terms of our ability to bring value to the plant, it's very low. So when you're mapping, after you're mapping the needs, now you're mapping the data. So one thing is the data to achieve the goal. The second is the data to really see that that the goal was achieved. Because if you don't have that data, you'll finish your implementation, and you don't have any way to evaluate your success, and that's of course something that a situation that you don't want to be in. The second thing that people are talking about when we're always talking to customers is we don't have historical cases. Okay, we don't know, especially when you talk about the part failure, we don't know how much, we didn't really register all the failures of the different parts, only the really big ones. And here I want to make a little bit of an order and ease the worry about historical problems, because let's understand a little bit about our situation in terms of analytics. Actually, you have a plant which is big with a lot of data, and problem can occur everywhere. I mean, it can be a small valve or a pump, or it can be a compressor. Problem can occur everywhere, and you have plenty of this time series data kept in your historian. Okay, now the one thing that you actually don't have, and it doesn't matter if you registered or didn't register, is actually identical historical problems. Because the fact that the pump XYZ failed once, for us, is looking at analytics, it doesn't bring us any value whatsoever. Okay, so actually, unless you have 30, 40, 50 cases, which are exactly identical, and under exactly the same conditions, they all happen in winter, and they all happen to the same pump, and they all happen under the same conditions, unless this is your situation, so it doesn't matter. The historical problems, whether you recorded them somewhere or you did not record them somewhere, would not bring us any value in terms of enhancing our analytics. Okay, we actually cannot really use them, because we cannot actually use them in order to predict failure. Because we're not trying to predict a specific thing, because this thing happened once or twice or 3 times. And in order to create a reliable prediction, you would need, as a rule of thumb, at least 30 cases which are the same. Okay, so in that respect, I wouldn't be worried about the historical cases, because we're actually not trying to predict a specific thing based on those specific cases. Now, I would just open the bracket here and just give you a taste of what we're actually doing. What we're actually doing is we're trying to define the normal for the plant. We're taking this plenty of data, and we're taking all this data and trying to define the normality for the plant. Now, the only problem with normality in the process industry is that it's very noisy, because the data is noisy, the plant is noisy, and there are so many tags, so the number of situations which are normal is just enormous. One option is, of course, to take only a few assets and focus on them. What we're doing, and again, this is just in the brackets, is to add context to the entire plant. This allows us to take the human knowledge together with the machine learning in order to really provide you a good result. And again, I won't go into too many details here. I would leave it for a future demo for any of you who would want and may contact us later on. So to summarize this point, the historical cases, if they're recorded, great. If they're not recorded, also great. In any case, they are not used for the analytics. So this was about the data. Now we have a question about the human factor. And I cannot underestimate the importance of the human factor, and especially the issue of management support. Okay, the plans that were most successful for us were the ones where the plant manager was involved in the project and was very supportive of the project. Okay, and I would say we had a plant where the plant manager had a bi-weekly meeting with the process engineer in order to look at the achievements of the system. Okay, and it doesn't mean that the plant manager really knows better than the process engineer to read the alerts or to, but it was a sign for the process engineer that this project is really important for the plant manager, and just by that, you know, the project moved forward. Keep in mind that all of us, all the process engineers, all the people in the plant, all the operation people, they all have their day job. And when you're trying to implement a new solution, unless management says, wow, it's really important for us, there will always be other things. And in that respect, when we're looking at the main things that we're doing at preventing or telling you in advance that the part is going to fail, it's very important to map who are going to be your users. And for our case, what we have found is that it's good to start with the process engineer, but actually the natural place for this kind of system, which is monitoring the entire plant and looking for problems in the entire plant, and coming with those 2-3 alerts a day, is not to rely on the process engineer, but rely on the control room, which is 24/7, which is all the time there. But if you're looking at that, if you're implementing a solution in the control room, it must be really, really structured. Okay, you cannot rely on the process engineer, which is more, I would say, innovative, analytical, and so on. It has to be really, really structured. Where the process engineer is using another part of our solution, which is called the sandbox, which allows him to do all kind of historical simulations and look for root causes and find what actually may be the cause for different problems. Okay, so it's really important to understand and to map the users and to make sure that these users actually are ready for the analytical solution. Okay, so we're now talking mapping the entire, mapping all your plants, and for each plant you must know that you have the data, you have the management support, and there is an operation team who can actually have the solution. And then in terms of the solution, what we came up after many trial and error, we came up to the solution where you have to be really structured. Okay, you have a single operation in the control room. They can save or discard. And this by itself made things very, very clear. So there is a very complicated analytics behind the scenes, but if you're approaching now the control room, it has to be a very, very, very simple process where they can relate to the, basically operate the solution. Okay, so 2-3 alerts a day, save, discard, very clear, or forward it to the process engineer because it requires some other attention, and that's it. While you're monitoring the entire plant, this is basically what we found is the maximum capacity of those people. So if I summarize this part of mapping I would say the requirements for scale up. So for each plant, what we would hope is that you will map the need, the goal, whether it's part failure, process problems, or other. Map the data, whether it's the actual data, sensor data, or the data that need to prove the achievement, and map the human factor. And the last point here is that if you're seeing that you have a problem across plants in terms of in terms of availability of the right people in the plant, then you should consider another option, which what we call the service center. Okay, let's not try to push too hard on the plant, but let's create a central location who would look at the alert, prepare them for the plant, and only the ones which are really important will provide to the plant. This is also an option, and it's actually not necessarily a bad one. So these are the factors of mapping that we are seeing. Now I want to touch in the next 10 minutes the next topic, which is how to build the right implementation process. Okay, so we are now mapped our 20, 30, 10, 1 plant. We understand what is the need, what the data available. We know that we have the human resources. Now we want to implement. Okay. Now, in the early days, we were here. Okay, people were so high on technology that nobody cared about the mapping. Then people got disappointed, and I think we saw it through 2018. And we are now in the area of scale up. Okay, we got disappointed. We understood that not all our dreams will be fulfilled by predictive analytics, but some of them will. And now let's build it in the right way. And in that sense, what I would like to tell you or to basically from what we're seeing is that technology is matured. Okay. And it doesn't matter if it's our product, which is again excellent, or some other product in different fields or different needs or fulfilling different things. It's not about technology. Okay, when you're talking about predictive analytics, it's not about technology. And when you're running an implementation project, you're not testing the technology. And I think one of the biggest mistakes that we're seeing from customers is that they're saying, okay, we want to test technology. And it just doesn't matter. What I'm usually saying to these customers is, listen, these are the use cases. See, there are many of them. You can see how successful we were in other places. And if you really want more, you can talk to reference customers. But it's not worth the effort of testing technology. It's not it. Technology is there. Okay. The other thing that most organizations already have today, and which was not the case, even a year or 2 years ago, is that they have enough knowledge to select a solution. Okay. And if you don't feel that you have enough knowledge, there are always some kind of consultant that can help you with that. So the process of testing the technology is over. The process of selecting which technology would work best for you is also something you would probably be capable of doing in most organizations. So this is not the issue. Okay. Now, another thing that is important is that the business model for most software, ours and I think also most of other software, is an annual subscription. So it's not that you're now coming to a 5-year contract or 10-year contract where you're actually implementing, and whatever you decide now is there for life. It's an annual subscription, which if something better will pop up next year, you can always switch. Okay, so those are the important market conditions. Okay, it's important baseline when you're making a decision. Now, when we started our implementations, we were piloting. Our recommendation now is, instead of piloting, think about it as a subscription. Okay, because you're not testing the technology; it's already there. You decided what's the best solution for you, and anyway, it's only for a year in terms of commitment. So let's not call it a pilot. Let's call it a subscription. And instead of running as we were running before, our implementation for entire plant is a 2 weeks implementation, and we were running 3 months. After that, we kind of understood that, it's better to split this implementation to first understanding the problems and then do the actual implementation. In our case, it's a modeling workshop, but still we ran for 3 months, and still we called it a pilot. Okay, what we're offering customers now, we're telling, listen, let's do the preparation, IT preparation, server, and all that. We're running usually on site, so it's not a big problem. Do a 2 weeks implementation, and then run online for at least 12 months. Okay, and in a sense, this is providing us, you may think it's only semantics, but it's providing us a different state of mind. Okay, it's a different state of mind from the team. The team, the operation team, which is actually the user of the system, understand that they have a solution that they can use, and they will see value, but they're not expected to test some kind of technology. They're not expected to become suddenly a data scientist or giving ranks to a technology solution. We assume that the mapping of the needs that I talked about it in the first part of the presentation, we assume it's not perfect. Okay, so if you're saying we're taking a subscription for 1 year, you provide enough time for pivoting, for adding data, and so on and so forth. Okay, so all these things are the actual approach to the project is now we're scaling up. We map the needs of each plant. We know that for this plant we selected this solution, and now we implement that. And worst case scenario, in 1 year from now, we'll implement something else. Okay, or we'll implement something in addition because there is another need which this tool doesn't provide. So our recommendation now is after you map the needs, implement the project for a year. Okay, it makes much more sense, and it provides a much better chances of showing the value during the time. So this is I think an important point. Now, another thing that we focus on is the training and vendor support. Okay, we assume that the operation people, process plant, control room, they are not data scientists, and they will not be, and there is no reason for them to be. Okay, our solution doesn't require them any knowledge in terms of analytics. They only need to know their plant. Okay, but now they're looking at the results, and for many of them, it's a change of paradigm. Okay, because actually, until now, they were chasing fires. Okay, things that are urgent. The fact that I'm telling you, you have a problem here, and it's not going to fail tomorrow, it's probably 2 weeks until it's going to cause you a problem, is something which is a change of paradigm for many of the plants, because they're chasing the fire of today or in best case tomorrow. Okay, now you're starting to prepare yourself for the longer term, and if you do it correctly, you will not have the fires of tomorrow, because actually most of the things will become predictable and predictable and predictable. So you'll take care of things in an orderly manner rather than on an urgent and expensive way. But this is a change of paradigm which you need to address. The second thing is the definition of a problem. Okay, all of us know the control limits in the control room, and if it's above or below a certain value, then we have a problem. A problem in analytics is much more fluid. Okay, and it's not about control limits. Each alert that we provided, none of them was ever over the control limits, because for that you have control. You don't need a sophisticated analytical machine learning AI solution. You just need the control. So actually, if you're implementing this solution, you have to understand that now the definition of a problem is more fluid, and it will always be within the normal range, within the control limits. Okay, and just to give you an example, this is an alert. This is a case where we identified the methane leakage in an ethylene plant. Okay, and the important thing, by the way, in this case, we gave the alert very, very early, still within the control limit. But you see that something in the relationship here between those two tags has changed. Okay. By the way, the nice thing about this example is that, and that's the beauty of SamGuard, of our solution, is that we didn't give any alert here. You know, usually when you go to conferences, people show you one peak and say, oh, this is the alert. In the process industry, in reality, you have many, many peaks. You have many, many changes. Okay, the real beauty and the real thing is to find the changes which matters. Okay, and this is where we gave alert here, but again, it was within the control limits. Okay, this is another case of failure of a joy compressor. Okay, and in this case, actually, what you see here is a differential air for the filter of the compressor. Okay, thank you very much, and apologies for the short thing, but so we were at the joy compressor failure, and again, the idea here is that everything is within the control limits. Okay, and it's not necessarily the things that you expected would indicate the failure, and therefore the team need to be ready and need to know that there are things. It's a change of paradigm. It's not you act only when things are below or above the control limits. It's more fluid. You get an alert. You need to think a little bit and act upon it. So these are the takeaways from these two. In terms of support, in order to help the team cross this paradigm, what we're usually doing in terms of support, we of course support the IT during the preparation phase, but more importantly, we believe in on-site implementation workshop where we work with the operation team in those 2 weeks in order to set up the solution, train the people, get them going, and I think this is one of the important starters for the project. Once this is going, as I mentioned, we have a 12-month period where everything is running. Usually we do a weekly or bi-weekly call with each of our customers. And again, this is answering questions, seeing that things are moving in the right direction, and making sure that everything is set into finding the right path within the operation processes for the analytical solution. So if I summarize this implementation point, it's really hard to define the implementation in the right way, to define this implementation not as a pilot, to set the right period. Our recommendation is to go with 12 months, and to make sure that you have the right support. Again, the people in the plant need to go through a paradigm change. They need to think in a little bit different way than they're doing today, and we find that this is important. Now, in the longer term, most of the organizations we work with have more than 1, 2, 3, 5, 10 plants, and at that time they start to build their own in-house capabilities in order to support more and more plants. So with that, I would like to kind of wrap up of these 2 points where we first talked about mapping the needs and resources of the plants and talking about the implementation process. And if at this point we have 10 minutes left, I would like to go back to you, Kyle, and open it for questions.
Okay, thank you very much. It's time for the Q&A. So a quick reminder to anyone who missed it, to take part, please type your questions into the box in the top left-hand corner of your screen, click submit, and we'll have some time at the very end to address any questions or thoughts you may have. All right, which is now. Let's start with, a plant is made of systems/subsystems and equipment. How do we address these individually and then move upward?
Okay, so basically, what we're when we're looking at the plant, we're looking holistically. Okay, the idea is that every pump, valve, filter can get clogged, heat exchanger, and so on. So the idea is to cover the entire plant. And the interesting thing about the process industry is that everything is affecting everything. Okay, so if you're looking only at the valve without looking at the entire things that are affecting it and where the flow is and so on, actually you're missing the point. So what we're doing, we're mapping the plant top down. So we're mapping what are the plant, what are the main subsystems and subsystems, and actually doing this hierarchical breakdown. The second thing that we're doing is we're doing functional breakdown, and we're connecting those two mappings into one plant model. So when you're doing that, you actually understand how everything is affecting everything within your plant, and therefore you can clean noise. Okay, some things that are happening, and if you look only at the valve, it would look completely abnormal, but when you look at the entire system, you understand that this is completely normal. And you're able to understand the more remote root causes that are affecting each other. So our approach is look at the entire plant, do not look at part. It's usually both in terms of value and in terms of accuracy. The more you cover, the better your accuracy and the better the value you bring to the plant.
Okay, very good. We've got a question here asking, the predictive analytics solutions are new technologies. How can we make sure they will bring us value?
That's an excellent question. And I would separate between the technology and the value. Okay, because the technology is working. Okay, and we can show you a really nice use cases, which I showed only some, and it's working. The question of value is a different question because the value relates to the need. So the most important thing in order to really know if it will bring you value is to map the need. If you map the need, and you found that there is a real need, let's say availability. Availability is 85%, 86%, and you want to get it higher. And most of these availability losses are because of unplanned shutdowns or unplanned failures of equipment. And then you map the data sources, and you see that you have pretty good data. I can assure you, and be pretty accurate that you'll get value. Okay. If at the same time you have a plant with 99% availability, and now a very enthusiastic team and people really want to implement digital solution, I can, most probably assure you that you won't see the value. So the value is not about the technology, it's about mapping the needs of the plant. And if the plant really have a need, the technology is there. And it's from us, from our competitors, it doesn't matter, but eventually according to the need, you select the right technology. But focus on mapping the need.
Okay, thank you very much. A question here is asked, how was your solution a better fit for complex plants? Okay,
the thing is as follows. In a complex plant, since you cannot really look at one part at a time, you have to find a solution for thousands of sensors, okay, which are in the rocky environment of the process plant. And still you don't want to bring false alarms, because false alarms is a killer of any analytical application. If you put in the control room a false alarm, and many of them, they have it from the control. They don't need a new analytical machine learning AI solution in order to get the same garbage that they're getting anyway. So you have to make sure that you have only 2-3 alerts a day, and they're accurate and they bring value. Okay. Now, in order to do that, you cannot only rely on the data, okay? Because the data is scarce, and is pretty rough. Okay. What we do in order to avoid that, and I touched it in one of the slides, is we try to map or to create some kind of a very simplified digital twin or model of the plant. And now we use the machine learning, and this model actually encapsulates or captures the knowledge of the operation people about their plant. So what we're running what the machine learning in our solution runs, it runs all these lots of data, a lot of data from the entire complex plan, but kind of rule out and clean up the noise in order to bring those few alerts to the control room. Okay, so especially in complex plans, especially when you don't have many historical cases, so you cannot really do prediction, and especially when you're trying to cover everything, I think our solution at Standard is basically probably the best solution that you can find.
Okay, very good. Someone here has asked if you could elaborate on the paradigm change.
There are many, but I would touch the paradigm change that I talked about earlier in terms of the operation people. Keep in mind that the way of doing things now in most plants is, especially when it comes to equipment failures in operation, is to first we react to things that already happened. Okay. The second thing, we react to things that breached the preset control limits. Okay, these are the two things that we react to. Now suddenly there is a tool here which tells them, listen, you have a problem starting to develop with pump ABC. The data shows that it's still in the control limit. Okay, nothing is happening with the pump, and now they still need to decide what to do. And actually, they can decide that they have some time to do it because the pump is not in a critical condition. If it was, probably it would get to the control limit. And this requires some thinking, and this requires some open-minded, and this requires a different action than they used to have. So, and this is not very easy, or not easy for everyone in the control room, in the operation team of a process plant. So, having things predictive versus reactive is a major change. Is a major change over time, and again, the sooner you start with that, it gives people more time to actually absorb the change.
All right, very good. I think we have time for one more question. So someone said, you talked about the human factor. Who do you see as the owner of the project? Who should lead it?
Well, it's a great question. From our experience, the person that usually leads the project is the process engineer. Although people always, there is a buzzword about predictive maintenance, but from our experience, we don't see the maintenance people so much. They're involved, but in less effect. So I would see the process engineer as the leader, reporting to the plant manager, who is the big sponsor, and the control room is actually the first line of users. That's the structure that we saw that worked best. Again, there are other parts of the organization, such as the IT, which from our experience are more of a supportive function, but are not really the users or the owners of the project, of the product.
All right, brilliant. I'm afraid that's all we have time for today, which just leaves a big thanks to Chen for what was a great presentation, and of course to Recognize for sponsoring this session. To everyone watching, you're going to receive an email shortly letting you know how to access the on-demand version of this webinar. Or you can always get to this through our website, which is www.business-review-webinars.com. Thank you all once again, and I hope everyone enjoys the rest of their day.